Okay, let's dive right into this. Welcome to today's Explainer, where we are absolutely tackling the monumental final challenge of system design. If you've been following along with this journey of mastering system architecture, you know by now that theory really only takes us so far. Eventually, we have to roll up our sleeves and build. So today, we are unpacking the ultimate capstone project, designing a fully scalable e-commerce platform. It is literally the ultimate test of everything we've pulled from the source material, bringing every single concept together into one massive, highly functional blueprint. To tackle an undertaking this massive, we're going to break down the blueprint into 4 distinct phases. First up, the Day 30 challenge. Second, we'll look at core e-commerce features. Third, scaling the engine. And finally, deployment and defense. All right, starting with phase 1, the Day 30 challenge. Day 30. We've officially reached the climax here. We're well past the point of just learning the basic textbook definitions of servers and databases. This is the exact moment where all of those isolated technical concepts have to finally converge into one cohesive working masterpiece. And what exactly are we building? We're talking about a production-grade system. That means it's one complete system, it's fully documented, and it's built from the ground up to handle real-world, scalable operations. You know, this isn't some simple beginner project that runs perfectly fine on your local laptop. No, it has to survive the completely unpredictable, highly stressful pressures of real users out in the wild. And the ultimate proving ground for a test like this? Architecting a scalable e-commerce platform. It's basically the perfect storm of system design because it demands a flawless user experience, incredibly strict data consistency, and the sheer computational power to survive sudden, massive traffic spikes. Let's move right into phase 2, core e-commerce features. This is all about the user journey. Because every great architecture really starts with that user journey. Step 1 is authentication, securely identifying exactly who is logging in. Step 2 is search, which means finding that one perfect item hidden inside a massive inventory. Step 3 is the shopping cart, and this is a highly dynamic state that needs to be incredibly fast, but also persistent. And finally, payments. And here's the kicker. If literally any one of these steps fails, the entire platform just falls flat on its face. When we group all these visible features together, we actually expand way beyond just authentication, search, the cart, and payments. We also have to integrate a dynamic product catalog to serve up all those item details, an order system to reliably track purchases, and notifications to keep the user actively informed every step of the way. These pieces come together to form the complete interaction loop, the very elements your customers are actually seeing and touching. Which brings us to phase 3, scaling the engine. Time to talk back-end performance. Now, this is where things get super interesting. It's the stark contrast between the visible architecture, like the catalog and orders that the user actually interacts with, and the invisible architecture. A shopper is never going to see a message queue. They'll never know about your database replication. But without that heavy lifting behind-the-scenes plumbing, those visible features would grind to an absolute halt the second a busy holiday sale kicked off. To actually manage all that data speed and flow efficiently, we rely on some very specific back-end performance components. First up, Redis caching. Think of this as the system's short-term memory. It temporarily stores frequently accessed data, so we don't just completely crush our main database. Next, we use message queues to handle background tasks, ensuring users aren't just sitting there staring at a spinning loading screen. Finally, database replication makes sure our data is highly available and can absorb a massive volume of reads spread across different servers. But wait, what happens when a massive flood of users tries to access our system all at the exact same time? That's where traffic management comes to the rescue. By integrating an API gateway, we create one unified, highly secure front door for all incoming requests. Then, load balancing steps in, basically acting like a super efficient traffic cop. It evenly distributes that massive wave of shoppers across multiple servers. That way, no single server catches on fire from the load, while the others are just sitting around idle. All right, finally, we reach phase 4, deployment and defense. Welcome to the infrastructure vault. Look, you definitely can't just deploy a complex e-commerce platform, walk away, and just cross your fingers hoping for the best. Continuous monitoring is absolutely crucial. It allows you to keep a real-time pulse on your system's health, alerting you instantly if, say, a server suddenly spikes at 3 a.m. And then logging steps in to give you the detailed historical record you need to play detective and figure out exactly why that spike occurred in the first place. Down at the foundational layer of all this, we utilize Docker for containerization. That ensures our code is going to run consistently no matter where it actually lives. We layer that right onto a flexible cloud deployment architecture. But listen, absolutely none of this matters without a dedicated, impenetrable security layer. We have to guard highly sensitive user and payment data from relentless, ongoing external threats.
But here's the reality check. Even with the absolute best architecture in the world, unexpected, catastrophic failures will happen. Data centers literally go dark. And that's exactly why every single production-grade system must have a robust disaster recovery plan. You have to be able to survive the absolute worst-case scenario. Knowing exactly how to rapidly restore your entire system from backups, that is the true dividing line between just a good design and a truly production-ready one.
So, let's recap. We've mapped out the entire user experience, we've designed the invisible, high-powered scaling engine, and we've locked the whole thing down with robust defense and recovery strategies. You now have the complete architectural blueprint for a Day 30 production-grade capstone project. The only question left to ask is this: you have the blueprint. Do you have what it takes to actually build it?